All right, let's kick it off, folks. So cloud migration without fear, a metrics-driven approach. Intros, Kamala Dasika.
Gordana Neskovic.
And Pontus Rydin.
Hello, everyone. Good morning. So I thought we would kick off this whole presentation with this guy right here. Everyone familiar with him? Anyone who doesn't know him? So it turns out he is actually one of the most stolen comic strip on the internet because everybody forwards Dilberts to everyone else and they don't do licensing. I did licensing, so I'm really proud. Yay. So he is the second most stolen item on the internet after money. So he's popular. So it's really fitting today to start our project, or this talk essentially, with Dilbert, because in many ways we feel the same pain he's feeling in this particular instance, right? Where his work is not considered valuable. So in the Cloud Foundry tradition, Dilbert's situation here is really not that uncommon, right? And lots of organizations really have the challenges in keeping their software development lifecycle focused on the work that's above the value line. Things that translate to customer delight and frequent customer delight. So keeping this in mind, and in the spirit of cloud native, VMware IT has adopted a DevOps culture for its internal teams and has taken an aggressive cloud native application development strategy. And they've outfitted the environment with the ability to run containers, an orchestration layer, microservices, Spring Boot, Spring Cloud Services. And of course, the key component of this cloud environment is Kubernetes and Cloud Foundry, Spring Boot, and Spring Cloud Services. That way, developers can deploy stateful containers or microservices and dynamic orchestration layer on top of these, on this platform, and essentially get to work immediately. Now, as we all know, an application actually needs more than just the platform to run. It actually needs a slew of other things like an integrated database, messaging, monitoring. So the environment actually provided a way for developers to quickly access those resources, and the business benefits have been pretty significant on the operational side, as you can see. So the team is actually able to onboard projects in less than a day, most of the developer projects, and there's actually a 95% reduction in the number of support tickets that they're seeing for resource provisioning, right? So this is a pretty traditional use case. So this is all the benefits that you're seeing on the ops side. Now, what about the developer side, right? And one of the beneficiaries on the developer side is this team called the VMware Skyline team, where they've taken advantage of this abstracted infrastructure and have started to develop and migrate applications to the cloud platform. So what's VMware Skyline? So this team, the VMware Skyline team, is responsible for end user experience. They're part of the support toolbox inside of VMware for the premier customers, and they essentially take advantage of this environment to provide value directly to the end users of VMware. So VMware has 100% penetration in the Fortune 500 companies, and they kind of need a lot of support for those environments, and specifically for production support and for premier services that caters to vSphere, NSX, and vSAN, which is a big part of the portfolio. So the user community for VMware is actually fairly large, and they're quite helpful, and they kind of trade ideas and help each other solve and resolve certain issues. However, sometimes you want to be able to troubleshoot these things yourself, and you want to be able to cut that time down short in a way that you can get to the root cause fairly quickly. So the Skyline team was born. So what they do is actually collect the user profile, the configurations, and the general architecture across integration information, and they analyze it and run it through machine learning to make personalized recommendations as to what their configuration needs to be. And so the Skyline team actually runs on Cloud Foundry. And it spans several foundations, about 8,000 containers per foundation, and essentially uses, the product lifecycle is such that they use 2-week sprints to get from to production. So they're releasing new features pretty much every month or so. Now there are about 1,500 customers that are making use of this service, and so reliability is actually kind of a big deal. So if you're advising your customers about how to make reliable environments, you kind of need to look reliable yourself, and you kind of have to be secure yourself, and that's a big deal in the way in which you're handling sensitive customer information and things like that. So from an engineering perspective, what are the requirements? The kind of needs the team had, they really had to take a leap of faith in putting their app on Cloud Foundry. They have a large number of app instances. They do frequent deploys. They want to roll back quickly. The team culture is essentially built around you build it, you run it, you own it, right? So this, in essence, created a need for deep platform observability needs, right? And so it's not just a view of the applications that are running on the platform itself, but also the services that are running on the platform, the future services that are going to run on the Kubernetes platform, services that are running outside the platform that are running directly on virtual servers, et cetera. So now notice I said observability. I didn't say monitoring. So that means that the platform is actually held responsible for opening itself up to show what's happening inside it, right? That's the difference between monitoring and observability. It's like an extension of monitoring. So Cloud Foundry, being a modern breed of platform, already does some of this, right? And it provides a lot of visibility into the systems that are high-level overviews of what's going on with your application, of the system, and the life cycle of the applications that have crashed, et cetera. And it brings together all the logs and the metrics into the one place, the fire hose, to make the entire system easily available. Now, there are going to be some talks today about metrics and health watch and all these other ways in which you can actually see inside the system. And some of the best practices observed by SREs are going to be captured in the playbook surfaced by Pivotal Health Watch. So do catch those. But back to the talk. Although we're giving up some control with the abstraction layer that the platform is providing to the end users and to the developers, they're getting the advantage of more speed, resilience, and scale. And they're also getting the platform to tell them a lot more information about what's going on inside the system. So Gordana is going to take it from here.
Hi, my name is Gordana, and I will talk more about observability and what should you look for in order to get most information about your application, about the platform that it's running from, or about infrastructure, underlying infrastructure, and how to connect that. So let's start just with a glimpse of amount of information that you can get and how it, at least for me, it's not that consumable and I cannot extract information from here. So it's very daunting, that explosion of information. And besides this explosion of information, there is velocity component of that. It's very dynamic. Containers can spin up and vanish in a matter of seconds. So you want monitoring solution that can be very granular, maybe even 1 second granular, and bring you all that data. So velocity, scale of data, and you want a monitoring tool that can bring all your teams together, that can bring your developers, your operations, your even program managers, and exchange that information so that they don't point to each other and figure out who's guilty, but focus on solving the solution, on finding solution. So you want monitoring tool that can give you information starting from internet access, from that infrastructure, whether it's on-prem in some data center, is it hybrid or in the cloud or even multi-cloud. It can be AWS, GCP, or Azure, you don't care. You want all your information there. You want information if you're running Kubernetes, you want all Kubernetes component or Cloud Foundry, you want all platform components there. You want application information, you want standard, you want customized, and very important custom information. And for that, you're using open source. So you want all that stack. You want your information labeled so that you can cross-correlate and apply powerful analytics. So what you want from the platform is to get metrics, distributed tracing, and histograms. I don't know how many of you are familiar with distributed tracing. I'll just cover the basics. So for the metrics, you are tracking your KPIs over the time. You're taking the specific value, and you can add additional labels that the Pontus is going to talk about. What's the source? What's the container that it's running from, so that you can connect and see where's the problem. So they are very, you can compress that information and extract easily. So that's the value of the metrics. You use metrics for alerting and for querying. And then you need histograms, because it tells you, it's a distribution. You put your high velocity data into the buckets and see, where should I focus? Is this the anomaly that should I take care of, or I can have a coffee first? And then after the histograms, you want distributed tracing, because distributed tracing gives you visibility. It consists of the spans, and it follows your request from the beginning to the end. It goes through various services. You can see the critical path, and you can figure out where should you focus. So it gives you where is the bottleneck, or where is your and what services is failing. So this is what you should look for. And then the best practices about distributed tracing is you want vendor agnostic and language agnostic. You want to integrate that your services can be run on many frameworks in many languages, and you want to be able to extract all that information and bring it, collect it, and bring it into the dashboard. So you want that, and then you want to consider what's the effort you want to put in, what's the scale, and according to that, decide for open source or some enterprise solution. It is time-consuming to do this distributed tracing, so you want some help. If there is any SDK that can speed up your instrumentation, that's very welcome as well. And again, you should be able to see not just distributed tracing. You want metrics to alert you to the problem, histograms to figure out how prevalent the problem is, and finally distributed tracing to know where is the issue. And this is just a snapshot of possible open source and other integrations. So you want a solution that has many integrations, so that you can quickly get the out-of-the-box dashboard and easily customize it. And finally, before I give it to the Pontus for the live demo, you want, just to summarize, real-time end-to-end visibility through your application that you can fast troubleshoot. You want alerting and analytics behind it. And Pontus?
Yeah, sure. I got a mic here. Was there another slide for me here? Okay. Yeah, so the Skyline team, so full disclosure here, was the guy who actually runs Skyline was supposed to be here. He last minute couldn't make it, so I'm kind of standing in for him, but I think I got this pretty well, right? So Skyline team, they support over 3,000 customers, and they are big. They are really our biggest customers. The challenges that they had was that they knew what was going on in PCF, and they knew what was going on in their app, but they didn't really have that full stack visibility. When something went wrong, they couldn't tell if that was something that had to do with something in the infrastructure, or something in the application, or something in the database. They lacked that cross stack visibility. They lacked a good way of visualizing data, right? So yeah, they had the data, they could see it in HealthWatch, they could see it in a various bunch of other tools, Excel spreadsheets, what have you, but they lacked that end-to-end visibility and visualization, right? They also had problems spotting trends and things like that, right? So what they did was that they used the awesome thing that is the Logaggregator Firehose, right? Because anything that goes on at all in Cloud Foundry comes out on that Firehose. Just hook up a nozzle and off you go, right? And then they're feeding that into Wavefront by VMware, which is a monitoring solution that, we are VMware, so we happen to have that, right? So we're using that. There's a bunch of other open source ones, but that's the one we're using here. That's the one we're going to do in the demo as well. Now, that wasn't enough for them, because they're calling out to Azure, they're calling out to AWS, they're calling out to all kinds of different other pieces of infrastructure and other pieces of application platforming, right? So they had to feed all of that in and kind of process that in one single place. And that's kind of key here, right? You can't just, you can take things off the Firehose, but it's usually not enough, because it runs on your vSphere, you need data from there. It might run on AWS, you need data from there. So that was kind of the thing that they were missing. And then there's a bunch of auxiliary things, right? You can they wanted to have alerts maybe on PagerDuty or Slack or whatever. I don't think they used all of them. That's kind of just like a list of things that we have. But and then of course the visualization. So if we look at, I mean, this is just a quick, very high-level overview of what that analytics engine looks like. It's a bunch of ingestion logic, right, that ingests all these metrics coming in from our customers, usage, configuration, all that kind of good stuff, right? And then that goes into Redis instances. All of that data is stored in Redis. And then they have a multi-node persistent store that kind of stores, is the long-term storage for that. But kind of the short-term storage is Redis. And then they got a bunch of rules engines running on top of that. And that's what runs the ML, right? That's what says, hey, trying to figure out what's going on in the environment and things like that. So now I'm going to attempt to do a live demo. Let's see how that goes. So what I'm going to show you is kind of a day in the life of, come on, there it is. I think that should be it. All right, so of course.
You need to project it up there.
Oh, how do I do that?
Share. Best laid plans.
I got to do like mirror here or something like that.
Well, you were showing your slides before.
Well, that's in a different mode. I got it. Don't worry. Don't fret. I got 14 minutes left. We're good. Show mirroring options. How do I do that? Yeah.
Maybe you want to pull it over to the other side?
Yeah, but that's not going to work. How do I mirror?
There should be an arrangement tab on the other window.
Yeah. Oh, yeah, there it is.
Thank you.
Thank you.
I can give a million of these presentations. I really should know that. There you go. Okay, then let's make this a little bit bigger so people can see. Now, this is just, basically an idea, okay? These are kind of the basic dashboard that they're using, right? So they, of course, they want to be able to do things like, one of the things they really needed to do was to understand capacity. And that was kind of the title of this. I mean, how do you migrate an application into something like this without it being scary? Well, one of the things you got to do is you got to measure before to see how much capacity does my application need. You can measure that if you have a legacy environment, you measure it there, or if you have a test environment, measure it there, right? And here what they're trying to do is kind of understand how would that map to when you run things in Cloud Foundry, right? So that's what they did. They did a lot of measuring before and a lot of measuring during the migration, a lot of prediction before the migration and measuring during the migration. And then, of course, most of all, you got to measure afterwards. So this is kind of one of the dashboards they're having to, there's a kind of junk data on it, but this is one of the dashboards they have to kind of understand how they're looking in terms of capacity utilization. They're also looking at things like, hey, what's my trend in capacity utilization? This is over the last month, right? So they can kind of gauge how they're growing in terms of memory. They got some key KPIs in terms of growth figures and things like that. So pretty basic stuff, right? Of course, what they can also do is they can monitor various pieces of PCF or Cloud Foundry. Shouldn't say just PCF because it could be, come on, nice and fast internet in here. This is going to go well. So they can monitor things like, all the different components, the containers, the Diego cells, what have you, things like that, right? So let's move on to the Diego cells, right? So here we go. So they can monitor things like that. Again, still pretty basic things, but these were things that they needed to visualize. They had no way of visualizing this. They had no way of kind of quickly getting to this information. Where it gets really interesting is when you start doing things like this, right? This is basically kind of a busy dashboard. What they're using this for is to look at a problem at an application, from an application point of view, and then drill this down through all the layers. Everything is serverless today, right? Yeah, no, of course. Everything runs on infrastructure. I mean, come on, who are you kidding, right? There's infrastructure somewhere. In their case, they ran it on vSphere. Probably some of you run it on AWS or something else, but in that case, they ran it on vSphere. So their challenge was, how do I know when something is going on in my application, whether that is actually due to something that goes on in vSphere? Maybe it's like a bad network card on a server, something really like super physical, right? So what they did is they built this dashboard that basically lets them start at an application layer level, go down through the PCF stack, look at containers, that kind of stuff, and then go down all the way to virtual machines in vSphere. Now, Cloud Foundry is nice enough, if you've ever looked at it, they actually tag all the VMs they create, and it tags it with things like the job and a bunch of IDs and things like that. So it's possible to say, hey, this application running in that container is actually connected to that physical server down there, right? So one of the things they need to do was exactly that. So they built this little dashboard for finding a resource in PCF, right? So hey, I got this thing here, my Diego cell, yada yada, it runs there, and it's actually on that ESXi host. So that's kind of cool, right? I mean, you get that immediate kind of navigation, and you can drill down to, say, the metrics about the network cards on that physical host. But it actually took it one step further. And in this case, I'm just to get a good example, I'm kind of running it on generated data, so forgive me for that, right? But this is just one example, right? So we have this is the performance of some application, and what can we say about that? It's spiky, right? Every once in a while that performance spikes up. And I have no idea what's going on. I mean, I could go out and I could look at all the different metrics. You remember that chart with the gazillion metrics on it? I could look at that chart or break it apart and look at the different metrics. But one of the things that you need your metrics platform to be able to do, and which they could do here with this metric platform, is to do correlations. So they said, okay, I want to take a bunch of metrics. Behind this is a bunch of metrics in terms of, this is basically a compound metric that is made up of CPU latency, CPU usage, things like that, right? And I want to correlate that with those spikes. Is there anything in my metrics on my VMs, in this case, that correlate with those spikes? And guess what it did, right? It found, okay, these are 6 candidates. 6 Diego cells have a CPU behavior that kind of maps to that waveform, if you will, right? So it kind of maps to that behavior. Cool, now I have some candidates I could go look at. Now, what do they have in common, those 6 Diego cells? Well, wow, the net here is really...
It's kind of like behaving like an application would when it's overloaded, right?
La la la. Want to do a little dance or something? No?
A little bit.
All right, here we go. Perfect. Right. So okay. So now I'm able to look at my CPU correlation. I can see that there's really those 3 Diego cells that have a big problem. Okay. What do they have in common? Well, let's do one more correlation. Let's say, hey, which host are they running on? Well, happens to be that they're running on that host, which is 192.168.60.10. I should use DNS names instead, but yeah, whatever. That's what it was called, right? So that's kind of the whole idea, right? To be able to go from a problem in an application, drill through all these layers automatically, to be able to do that correlation. There's a bunch of tools on the markets that could do that, and we argue that you probably, if you're really serious about this, you need one of those tools, right? You need something that could do the cross end-to-end correlation. What you probably need as well is you have a bunch of business metrics, right? So what they did, this is actually live data. The other one was from a demo system. This is actually live data from Skyline right now. So they have a bunch of business metrics, and this is a mix of a bunch of everything. So they had some code that's just instrumented through Drop Wizard, I think it is, that kind of reports this SLA metrics. Then they had a bunch of other things that are coming from this Firehose. So the Redis metrics you're going to see in a second, they come from the Firehose. And they have other things that come from, I think they had some MySQL instance somewhere that's not even sitting in Cloud Foundry, right? So what they're doing here is they're taking all that data from different sources and then mashing it up here. So this is basically the NOC view, right? Hey, are we doing okay? Well, 99.98% of our reports finish within the SLA, so that's good. I guess basically we're doing pretty well here, right? We're starting to see things like how long does it take to generate reports? How many do we generate per day? What is my inventory of report looks like? How long does it take to execute these rules? Again, these are all business metrics, but they need them to be mashed back into everything else here. And I think you had some other...
Do you typically see the operator kind of owning this or the developer kind of owning this? Might be good for folks to know that.
Well, I mean, it's DevOps, right?
Right.
So I mean, they have, and I love that they're not calling it DevOps because it's so overused, but they say you build it, you run it. That's their philosophy, right?
Yeah.
So they are really, the operator of the application and the developer are kind of the same. What they don't do is that does not stretch into the infrastructure. So the infrastructure is actually managed by a different team. But because they have this cross platform thing going on, they can now, when they have to go to the infrastructure team, instead of saying, hey, something is broken, they can say, that thing over there is broken, fix it. And they can see things like the ratio between things in queue and how many things are completed, so they can see, if things get stuck in queues and stuff like that. So it's kind of neat. The other thing they're doing, which is kind of interesting here, this is also more of these business metrics, but they're also monitoring deployment. So this is when they deployed new code. So let's zoom in on that little spike there. Bada boom and sync. And I'm not sure we're going to see anything here. But what they're doing here is like they're correlating those code pushes with their SLAs. And as you could see, it doesn't look like that affected SLA much. Like everything is kind of still doing well. But that's also really important, right? Code pushes is a metric that people tend to forget. Code pushes should be a metric, and it should be correlated with everything else, because that's how you find those hidden little things that go bump in the night. That's really useful. And I wish I had an example where code pushes broke something, but I guess they're good coders, so that doesn't happen. Finally, since we have a few more minutes here, let's look at one more thing.
3 minutes left.
Sorry?
3 minutes left.
Yeah.
3 minutes, yeah.
Now, I just wanted to look at distributed tracing, and let's do that really quick here.
And that's specifically relevant to microservices.
That is specifically relevant to microservices, right? So,
Which is something that you probably wouldn't need if you were coming from a monolithic
exactly,
application
right?
experience, yeah.
So, let's see if I find some interesting data here. Here we go, right? So here's a situation, right, when I have I have a spike in performance, right, or a spike in response times. How do I troubleshoot that, right? And I have a bunch of microservices. Well, I could look at the other microservices performance, and I can see if I see any correlations there, right? But sometimes you need to go from this kind of high-level view, not to another tool to look at things, but you need to be kind of in place, go straight into things like tracing, right? So you need to be able to say, hey, yeah, that spike there looks really bad. Let's see what we can see. Can I go in and maybe look at traces for it? Oh, look at that. Okay, cool. So now I can actually see into each transaction here and see where's my bottleneck. In this case, bottleneck is in that pricing service, right? Only reason I'm showing this is to understand that it stretches a lot farther than just looking at application to infrastructure. You actually need to be able to take that leap from the high-level KPI kind of view into distributed tracing. And you kind of, if you want to build this right, you kind of want to have a tool that could kind of stretch those. So I think that is all the time we had. We may have a minute or two here for questions. Yeah.
Or you can always ask us after the show as well. I mean, after
You can
we're
ask
done
us
and we're out here.
out there, and I'm at P Rydin on Twitter. I love Twitter followers, and I love to chat with people. So, yeah, any questions?
We have 1 minute.
Wow.
Yeah.
Quite impressive, maybe.
They don't. I have.
Yeah, ask away.
So what's the difference between monitoring like this and CloudWatch? Health Watch that's provided, for instance, with Cloud Foundry.
I mean, I like HealthWatch. It does a bunch of really cool things. Like it, for example, it tries to run certain commands and it tries to do pushes and things like that and measures that. What it does, I mean, it's very obviously Cloud Foundry focused, right? It's focused on Cloud Foundry. It can do things with that information. But what it can't do is to
Look outside the system.
look outside the system. There you go. Look outside the system. It can't do the collection of information from outside the system and correlate with that, right? So, you know, if you use HealthWatch and love it, keep doing it, right?
Yeah.
But if you have that nagging feeling at night that, hey, I wish I could see more, then there are other tools out
There
there.
are other tools out there.
Look
Yeah.
for that.
All right.
Thank you.
Thank you.
Thanks, everyone.